Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. It gives me great pleasure to introduce our presenter for this afternoon, one of our first presenters, Dr. Thien Wan, who's currently Dean of School of Computing and Informatics at University Technology Brunei. Dr. Thien Wan is a senior lecturer and the Dean at the School of Computing. He earned his Bachelor's of Engineering from the University of Glasgow, United Kingdom, Masters in Science in Data Communication Systems from Brunel University, UK, and his PhD from the University of Queensland, Australia in 2013. Dr. Au is also the head of IoT Research Cluster at UTB. His most recent research work includes using sensors for house monitoring based on computer networking, Internet of Things, Android system, intelligent agent system, and e-learning, experiential learning. Some of his works were published in various international journals and conference proceedings. He has also recently completed a few projects, such as co-investigator, such as providing an efficient and reliable ICT infrastructure for smart grid data analytics through fog computing, mathematical wall, and development of software agent-based smart prepaid wireless energy meter. Dr. Au also worked on learning management system and interactive e-learning tools for many years. He has published a number of journal and conference articles in education and related subjects. So, without further ado, now let me welcome Dr. Au and present his topic for today. Augmented reality, what happened when it was applied to Year 10 science class? You're welcome.
Thank you very much for the long introduction. I was a bit awkward to stand here and listening to what she has to say about me. Yeah, if you listen carefully to what she introduced me, I have nothing to do with augmented reality. Yeah? You see, all my research has nothing to do with it. Yeah. So how come I'm doing augmented reality here? It's about 2 years ago, one of my students, he wanted to do this particular project. He was a teacher. And he used augmented reality to apply to, he designed a very interesting lesson. Yeah? And then he used it for, he used it for one of the school, yeah? Year 10 science student. And the result was very interesting that I think I should share with you, yeah, taking this opportunity. Okay, I know this morning there was a very interesting augmented reality by the keynote speaker, but I wasn't here, but I heard it was very, very interesting. And I will talk again about augmented reality, but it's a bit downsized, yeah? Not the long version, yeah? Okay, so this is the outline. I'm going to do a bit of introduction, yeah, a repetition. Yeah? Probably Professor Mark has already mentioned about this. And for the benefit of those who don't really know what augmented reality is, yeah, and I'll talk about the application, briefly touch on the technology and the experiment, yeah, we did on Year 10 science students. We do it on redox reaction, yeah, chemistry, and the results and the conclusion. All right, it's becoming very popular now, yeah, because we had very powerful mobile devices nowadays, yeah. So it allows AR to be used everywhere, yeah. And what is this? Yeah, it's a real world with virtual text and image and superimpose. Yeah, you probably will use a monitor or helmet kind of thing, or goggles, glasses, windshield. Yeah, and you can accordingly, virtual text and image you can superimpose on selected object in the real world. Okay, so you are caught in between real and virtual. Yeah? It's different from virtual world. Yeah? It's augmented reality, so you have a bit of the real and the unreal. All right, so augmented reality is based on context-aware computing. Yeah, so it knows what is around. Yeah, of course you have to tell it to recognize things, and the real world and the virtual object, they coexist on the same wheel. Yeah, this is I got it from this researcher. Yeah, Jung Jun Moon. Yeah? Okay, a short history of augmented reality, and you'll be surprised. This augmented reality, the idea has been a long time. Yeah, yeah. And it's only recently, in 1990, Thomas P. Calder created the concept, and he phrased it augmented reality. Yeah? But it goes all the way back to the beginning of 1901. Yeah, yeah. It's been a long time. Yeah. So why is it important now? All right, the concept is old, but it becomes fully implementable now, yeah, and it is reliable, yeah. And due to the high resolution of our camera nowadays, and smart devices, yeah, so it enables very accurate image and object identification, yeah. But if you realize, augmented reality is about the identification, yeah, of object, yeah. You take your camera or your mobile devices and you will try to focus it onto some object, right? It need to be able to pick up this little image, yeah. So it need to be accurate, yeah. You don't want to project onto something and then it come out with different story, right? You don't want that to happen. Yeah, that's because of our advancement in our mobile devices now, yeah. And also the CPU and GPU on smart devices is very fast, and there's very reliable image processing, yeah. So that would allow it to identify object more accurately and to extract the features, yeah, which could be very subtle, yeah. Okay, the characteristics of augmented reality, and the user should be able to turn it on and off on selected AR functions, yeah. Compared to virtual reality, you feel less separated from the real world because you are with part of the real world. Yeah? You're not entirely on virtual world, so you still feel the sense of being in the real world. Yeah. Okay, the fantasy and illusion, of course, can be created and superimposed. Yeah? This is the whole idea. Right. This is the definition by Ronald Azuma. Okay, the real and the not real. Yeah. So if you see the real environment on your left hand side, and the virtual environment on the right hand side, so you mix it, yeah, then that become virtual reality. Not virtual, sorry, augmented reality. Yeah. So if you look at another definition by Paul Milgram, yeah, he's famous. Yeah, you can see it's been cited everywhere, and it's a combination of real world, virtual world, real-time interaction, and in the 3D. So the interaction of all these three become the augmented reality. Okay, it's application. Yeah, just I think this morning Professor Mark has mentioned about the application, yeah, on AR. Yeah, education is one of the big application area. Medical science, engineering. Yeah, this is just example. Yeah, and in military and disaster management. You see that alert thing, yeah? So it should be able to pick out something and then it says alert, yeah? And disaster management. Sports and entertainment, we all know this, yeah? In the games, yeah, a lot of games now is augmented reality, yeah? Tourism and sightseeing, yeah? Okay, the classification, you have sensor-based augmented reality, vision-based augmented reality, and hybrid tracking. Yeah, so our project, yeah, on the chemistry redox, lesson is based on vision-based augmented reality. Okay, this is the technology. Okay, I just quickly skip through here. And the workflow, okay, you have an AR system on the left-hand side and the user on the right-hand side. So you do the detection, then it should be able to do the tracking and with the content, and you do the video rendering, yeah? And you have the feedback to the user, and the user will interact, okay? So if you notice this rendering, that would require a lot of CPU, GPU power, and it also requires a lot of memory, yeah? You need to store the data. Okay, this is the process. Generally, there are 5 processes there. So you acquire the image, and you should be able to extract the feature, yeah? And you do feature matching, and there's some geometric verification, and then you associate the information retrieval. Now, a lot of work, I think the main thing is on the feature extraction, yeah? The feature extraction, there are so many algorithms being developed, you know, the shift, the surf, and all this, yeah? So this is a big area in research, yeah? The feature extraction, which is the core for AR. All right, just the image acquisition is the process of retrieving an image from the camera, yeah? Feature extraction is based on the initial set of measured data, okay, and then from that measured data, they can extract the features, yeah? Matching, yeah? Number 3, the process of computing abstraction of image information to make some local decision if there's an image feature or not, which is conducted for all points. And you have the geometric verification, and you associate that with information retrieval, yeah? Depending on what feature you receive, then you try to match it, and then you will try to retrieve the right information, yeah? That would become the augment, okay, what do you call it? The virtual image, okay, to mix with the real world. Okay, this part is the experiment design, yeah? The one that we designed for chemistry student in year 10 science student, right? So this is like the flow chart of our experiment, yeah? So we have a control group and an experimental group, and we do it on science 1, year 10 science 1 and year 10 science 2 and science 3. Okay, you can see we have the control group and the experimental group. Okay, and before we do the experiment, we just want to see what is the learning style of the students. Yeah? We use the done and done inventory system, yeah, to try to figure out. So the student need to fill out some question, and from there we know whether they are visual learning type of student, or they are audio type of student, or they are kinesthetic, yeah. And then after that we expose the control group. The control, we use the normal teaching, yeah, to them, and then the experiment group, we use the augmented reality redox chemistry, yeah, and we do it for them, yeah. So before we do this, we give them a test, yeah. We do the pre-test, and then after doing the course, a lesson for a week, yeah, we just take a small part of chemistry, and then after that we do the post-test. And what we do is we use t-test to measure how significant between the control group and the experimental group. Yeah. All right, this is before we engage the student, and we try to measure to see what is the learning style. If you look year 10 science 1, which is the control group, yeah, most of them are visual, and followed by kinesthetic, and then auditory is the least preferred style of learning. And for year 10 science 2, we do the test using done and done inventory, and then we found that they are more kinesthetic, yeah? So they are more action oriented. They like to be involved in, yeah? And followed by visual and auditory. And year 3, we found that students are more inclined towards visual learning, and kinesthetic is the second, and the visual it's more or less the same, yeah? It's the same, sorry. So if you notice, overall, they are more visual, yeah? Students they prefer visual, followed by kinesthetic, and the auditory they less prefer. Meaning to say that probably we don't have to say so much thing when you're teaching. We just show them a lot of pictures and ask them to run around. Yeah. So, I mean, this is how the student's perception, yeah, on the learning, yeah. So more visual, followed by kinesthetic, and the least is auditory, yeah. And the learning style in terms of male and female, if you notice, the male is more kinesthetic learner, yeah, compared to the female, yeah. And the intervention of sample, control group, and experimental 10 science would be the control group. Okay, we teach the control group the topic on redox reaction, yeah, in a normal lesson. And for science 2 and science 3, the experimental group was involved in mobile AR learning experience, yeah. So this is the control normal class. So they are sitting very quietly, you know, try to listen, follow up on the teacher instruction, yeah. And this is the the sample of the image marker, right? So this image marker, if you get your mobile phone with the view reader and you focus the camera on your mobile device onto that, and you will get this kind of thing, yeah. So here we show the chemical element, yeah. We only design 20 chemical elements, yeah. We do not have the time to have all the chemical elements, yeah. So this is I think it's helium, right? 2 hydrogen, 2 electron is helium, isn't it? Chemistry, yeah. Yeah, so that I don't have the video. If I had the video, I can show that it will evolve, right? The electrons will evolve. What do you call that? It will move, yeah. Revolve around the atom. What do you call that? Neutron, right? The one in the middle is neutron. The one in the side is electrons, yeah. So it will circling, yeah. So this is the experimental group, and you see they interact with each other. They try to figure out and see how chemical elements look like, yeah. I mean, you can show the students pictures of electron, but this is like you see them real, yeah. It's real because it will evolve, yeah. And chemical element, they evolve in different direction, yeah. In the first what do you call that? I'm not a chemist. The first circle, right? You got first, second, and the second, they actually revolve opposite direction, yeah? And you can see that in this, you see that? They are not moving, of course, now, yeah? You have lithium, you have helium, and then calcium, yeah? Calcium has a lot of electrons, right? Yeah. Okay, the student very happy. You can see we didn't ask them to smile. We took a picture and they are very happy actually. Yeah. Okay, this is the pre-test result. Yeah. Before we do the test, before we start the lesson, we test the students. Yeah. If you see the t-test result shows that it's not significant. Yeah. Yeah. There are more or less no difference, yeah, between the experimental and the control group. This is a post-test. And you see that the median, yeah, the first one, mean for the control group is 26, but the mean for the experimental group is 42. It's just a big change, yeah? And the t-test shows that it is significant, yeah, because it's less than, you see the T44 0.0015, right, which is less than 0.5. So the result is significant. Yeah. So what I'm trying to say is that the augmented reality actually it offers opportunity to teach some subject which is very hard for students to conceptualize, and to see, by letting them see how chemical elements, that could bring a big change to the students' learning and their interest. Yeah? And I find that AR has great potential, especially in education. Yeah? Not all, I would say, but certainly in some, it will be very useful. And there's a lot of research opportunities, I think. Yeah. Okay, that's all I want to share with you today. And thank you for staying awake throughout this session. Yeah.